Morning students, this is class 11th maths, lecture 5th of chapter 1st, sets. We will discuss the topics complement of a set, properties of complement sets, practical problems on union and intersection, and solutions of exercise 1.4 which I have given you as homework in the previous lecture. So first is now complement of a set. Let U be the universal set and A be a subset of U. And A be a subset of U. Right? U is the universal set and A is a subset of U. Then the complement of A is the set of all elements of U which are not the elements of A. Complement is what? It includes all the elements of the universal set which are not the elements of A. That is basically the set U minus A, because U minus A contains the elements which are in U but not in A. And the complement of a set is denoted as a complement, right? This is the symbol for a complement. For example, if the universal set is 1, 2, 3, 4, 5 and the set A is 1, 2, then A complement will include the elements which are in U but not in A. So it is clearly 3, 4, 5, right? Now for finding the complement of A complement. Complement of A complement is nothing but A. Double complement on A is just A. Let us check this by an example. We have find out A complement taking complement of A complement, which is nothing but U minus A complement. So the elements which are in universal set but not in A complement are, which are in universal set but not in this A complement are 1 and 2, which is nothing but our set A. Clear? So complement of A complement is A. Now next is some properties of complement sets. First property is complement laws, that A union A complement is universal set and A intersection A complement is phi. As there is nothing common between these two, therefore their intersection is phi and their union is universal set. Now next is De Morgan's law, which states that A union B whole complement is equal to A complement intersection B complement, right? We'll take one example to understand this. This is De Morgan's law and both these 2 points are very important and will be helpful in many questions. So you have to learn them very carefully. So let's take one example to understand first part. Let U be the universal set 1, 2, 3, 4, 5 and 6. Let the set A be 1, 2, 3 and the set B be 1, 4, 5. So union of A and B will be this set, right? 1, 2, 3, 4, 5 containing all the elements of A and B. A union B complement will be the elements which are in universal set but not in A union B. So 6 is the only element which is in the universal set but not in the union. So A union B complement is 6. Now A complement will be 1, 2, 3 as lies in A. So the complement will include 4, 5 and 6. Similarly, B complement will be the points or the elements which are in universal set and not in B. So it will be 2, 3 and 6. Taking intersection, why we are taking intersection? Because we have to find out these two terms. We have find out A union B complement already and name it as 1. Now we are finding A complement intersection B complement. So A complement intersection B complement is 6, as 6 belongs to both the sets. Now let this name as 2. As 1 is equal to 2, therefore A union B complement is equal to A complement intersection B complement. You can similarly take an example for the second part by yourself. Now we have done earlier only that complement of A complement is A. Next is phi complement is universal. Why? Because phi includes nothing. Phi has no element. This is an empty set. Its complement will be the complete universal. And universal complement is phi. Why? Because universal includes all the elements. So its complement will be an empty set. Now we have to fill the blanks. A union A complement. What will be this? Universal set, right? Phi complement, that is nothing but universal set. Universal set intersection A will be the set A. Universal complement, which is the set? Empty set. Its intersection with A is phi, as phi does not include any element, so intersection with any other set will be an empty set only. Now, practical problems on union and intersection of sets. As we have studied union and intersections of sets, now we will study some practical problems. Before that, we will understand different types of Venn diagrams, right? So first is, if A is a subset of B, then the Venn diagram will be like this. Because A is a subset of B, so all the elements of A will lie in the set B. So set A will also lie in the set B. Clear? Second is, A intersection B is phi. If there is nothing common between A and B, then the Venn diagram will be like this. Since there is nothing common, so A will be a separate set in the universal set and B will be a separate set in the universal set. Next is, if A intersection B is not equal to phi, that is, there is something common between the two sets. So this set is A, this set is B, and the part shaded with this blue pen is A intersection B, because A intersection B is not phi, that is, A and B have something in common. Next comes the set A minus B. What this says, it means only A. This set is set A, this is our set B, as this set A will include this shaded portion and the portion A intersection B also, right? So this set is complete A, but the set which is just only A is the shaded part, because this part includes, this particular part includes A intersection B also. So only this shaded part is our only A, right? Because it includes B also. So the set A will be nothing but the union of this A minus B set and this set, which is A intersection B. Similarly, B minus A will be this set. B minus A is only B, as this complete set B includes this B minus A part and A intersection B part also. So B set is completely B minus A union B intersection A, and the only B set is B minus A. Next comes A union B. If this is the universal set, A set and B set, then union of A and B will includes all the elements of A and all the elements of B. So this shaded portion is our A union B. And so the set A union B is A minus B, this part, union A intersection B, and union this part B minus A. So we can say number of elements in A union B is nothing but number of elements in A minus B plus number of elements in A intersection B plus number of elements in B minus A. Now we will derive the formula to find the number of elements in A union B, right? So number of elements in A union B, we find it as like this. Now we will find the actual formula. So we got this, right? Now add and subtract number of elements A intersection B, right? So these are similar, number of elements in A minus B, number of elements in A intersection B, number of elements in B minus A, adding and subtracting number of elements in A intersection B. Clear? Now see number of elements in A union B as this part. A minus B and A intersection B forms A. So this part will gives us number of elements in A. Similarly, this part gives us number of elements in B minus number of elements in A intersection B. This is the actual formula to find the number of elements in A union B, and you have to learn this. If suppose three sets are given to us, A, B and C, now we will find the number of elements in A union B union C. So I can write it as number of elements in A union whole B union C, right? So number of elements in A union B union C. Now this is our A. I will treat this complete B union C as set B, as we have find the formula for number of elements in A union B. Applying that only, number of elements in A plus number of element in B minus number of elements in A intersection B. So A is our A intersection B is this complete B union C, writing it as B union C. Now number of elements in A plus now again applying this formula in number of elements in B union C. So n of B plus nc minus n B intersection C minus this as same. As we know, A intersection B union C, we can expand it by distributive law. So number of elements in this will be equal to number of elements in distributing it by distributive law. A intersection B union A intersection C, right? Now it is also a union of two sets. Applying this same formula, number of elements in A plus number of elements in B minus number of elements in A intersection B. So A is what? A intersection B. B is what? A intersection C minus number of elements in A intersection B intersection A intersection C. Right? So we got it as number of elements in A intersection B union C, number of elements in A intersection B, plus number of elements in A intersection C minus this intersection is nothing but A intersection B intersection C. Clear? So number of elements in A union B union C will be nothing but, now instead of this, right, we have find the value of this here. So instead of this, we'll put this value. So number of elements in A union B union C will be number of elements in A, number of elements in B, number of elements in C minus number of elements in B intersection C, and in place of this writing these values, also changing the sign because here it is minus. So minus number of elements in A intersection B minus number of elements in A intersection C and plus number of elements in A intersection B intersection C. So this is the formula which you have to learn for the union of three sets. Clear? Now for example, if number of elements in A is 5, number of elements in B is 3 and number of elements in A intersection B is 2, then find number of elements in A union B. So you have to directly apply the formula which is this, right? So number of elements in A union B will be 5 plus 3 minus 2, which is 6. So your homework is you have to do question number 11th and 12th of exercise 1.4 and exercise 1.5 complete. Okay. Now solution of exercise 1.4 which I have given you as homework in the previous lecture. So question number first is find the union of the following sets. We have to find the union of these two sets given as A. X is a natural number and multiple of 3. X is a natural number and less than 6. So first set A will be a multiple of 3. So it will be 3, 6, 9, 12 and so on. Other set B is natural number and less than 6. So it will include all the natural numbers less than 6, 1 to 5. We have to find the union. Union includes all the elements of A and B. So A union B will be X such that X is what? 1, 2, 4 and 5. We have not taken 3. Why? X is equal to 1, 2, 3, 4, 5 or a multiple of 3 because we are taking here a multiple of 3. So it will include 3. So we have not written 3 here. Right? Multiple of 3 will include all the elements of A. Second part is set A is X belongs to natural number and X is greater than 1 and equal to less than 6. Set B is X greater than 6 and less than 10. So set A will be 2, 3, 4, 5, 6. 6 will be taken as there is equality at 6. And for set B will be 7, 8, 9. So union will be all natural numbers as 1 is not there but greater than 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 9. So X will be greater than 1 and less than 10. There will not be equality on either side. Why? Because not 1, not even 10 are included in these two sets. Now next is question number 3rd. If A and B are two sets, if A and B are two sets such that A is a subset of B, then what is A union B? As you can see clearly from the diagram, is A, if A is a subset of B, then all the elements of A are in B. So the set A will lie inside the set B. So their union will be nothing but the set B, right? So A union B is B. Since all the elements of A are in B, as it is given, A is a subset of B. Now next is question number 6. If A is this set B, C, D, find A intersection B union D. These four sets are given to us and we have to find A intersection B union D. So for finding this, first of all, we'll find B union D. So B union D will be 7, 9, 11, 13, 15 and 17. All the elements of B and D. Its intersection with A will be the common elements of this set and the set A. So the common elements are 7, 9, 11. In similar way, second, we have to find A union D intersection B union C. So first of all, we will find the unions, this set and this set, and then take the intersection of these two sets. So union you can find easily. A union D is this set, B union C is this set, and their intersection includes 7 is in both the sets, 9, 11 and 15, right? Now question number 7. If set A is x is a natural number, set B is x is an even natural number, set C x is an odd natural number, and set D x is a prime number, we have to find the intersections of these sets. Now first is A intersection D. As we can see, D is clearly a subset of A. So their intersection will be nothing but D, because all prime numbers are natural numbers. So their intersection will be the set D, that x, such that x is a prime number. Next is intersection of set B and C. B is an even natural number set and C is an odd natural number set. As we know that a natural number can't be both even and odd. So intersection of B and C is 5. Now next is intersection of C and D. C is an odd natural number. D is a prime number. So their intersection will be all those prime numbers which are odd, right? Now next question is question number 8. Which of the following sets are disjoint? As we know, for disjoint sets, A and B intersection should be 5. So these two sets are given to us. First set is 1, 2, 3, 4 and the another set is x, such that x belongs to natural number and x is equal to greater than 4 and equal to less than 6. So this set is same. This set, another set, this will include the elements 4, 5 and 6, right? So these two sets are not disjoint. Why? Because 4 belongs to this set and 4 belongs to this set. So not disjoint because 4 belongs to both the sets. Next, second part is x is an even integer and x is an odd integer. As there is no integer which is both even and odd, therefore this set is disjoint sets. Why? Because their intersection is 5. Next come question number 10th. If x is the set this and y set is f, b, d, g, then you have to find x minus y. The difference of x and y will include all the elements which are in x but not in y. So the elements a and c are in x but not in y. Y minus x will include the elements which are in y but not in x. So f and g are those elements which are in y but not in x. As b and d belongs to I, bd belongs to x also. X intersection y will include the common elements of x and y which are b and d. Clear?